Alright, this is my second video on probability of disjoint and overlapping events. This problem, the first one I want to talk about, there are 63 cars in a used car lot, 60 of which have air conditioning or are silver. There are 80 silver cars and 56 cars with air conditioning. What is the probability that a car selected at random from the lot is silver and has air conditioning? When I read most of these word problems, there's three things I'm looking for: is ands, ors, and givens. If I have any of those pieces, it kind of tells me how this setup of this problem is going to go. So, for example, in the first, they talk about 63 cars and they use a lot, 60 of which have air conditioning or are silver. So I'm gonna put that in words on kind of what's going on. So they said AC or silver. So they gave us AC or silver, and they said 60 of those cards have air conditioning or are silver. So that's 60 out of how many total cars? Well, 63. 60 out of 63. It says there are 18 silver, 57 cars with air conditioning. So it might not be quite clear. There is an and there, but here's the deal. Notice how these are separate, the information. 18 silver cars. That's a piece of information, and 57 cars with air conditioning. If it was just one and it says there's 18 cars that are silver and air conditioning, that'd be different. But notice how there's two numbers there. This and is not the same and we're looking for up there. They're separate. If you continue on reading, it says, what is the probability that a car selected at random from the lot is silver and has air conditioning? So they want to know, let's do air conditioning and silver. That's what they're asking for. What is the probability the car selected at random from the lot is silver and has air conditioning? We don't know that. I'm going to put X. So let's try and figure out what these other numbers are. So in words, I can now see we're dealing with air conditioning or silver, air conditioning or silver, or in an and there. So it says 18 silver cars. So we know the probability of a silver is, well, there's 18 of those out of how many total? Well, 63. Then it talks about 57 having air conditioning. So probability of AC, 57 out of 63 as well. So we have a lot of pieces of information there. I have ors and silver AC. Now, typically these types of questions come with a formula sheet. What I would do is I'll look at, well, which formula involves an or, an and, silver, these. Now, it might be harder since we have words there, whereas a formula sheet would have A's and B's. But what the formula sheet's going to show you, it's going to say a probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So this is the probability of an event that is overlapping. And the reason why we know it's overlapping is you can have air conditioning and be a silver car. So up here I have my actual words. Down here I have my symbol. So all it's going to be is a little replacement. So A or B. This is obviously AC or silver. So the 60 over 63 is going to go there. I treated AC as A, so the probability of AC is 57 over 63. I treated B as silver, so probability of silver is 18 over 63, minus the probability of A and B. AC and silver, which we don't know what that is, so let's put an X there. So all we're going to do is we just want to solve this equation for X. So first thing I'm going to do is I'm going to clean up this right side, which means I could do 57 over 63 plus 18 over 63. And that becomes 75 over 63 minus X. So all I'm going to be doing is solve for X. If you wanted to convert all of these to decimals, add these two decimals, and then subtract it over to the other side, you could do that. I'm just keeping it in a fraction form to preserve any rounding till the very, very end. So if I want to get this X by itself, I need to subtract off 75 over 63, subtract off 75 over 63. So that's going to leave you with negative 15 over 63 equals negative X. Negative 15 over 63 equals negative X. x is almost by itself. I got this negative here, so what you would do is you'd multiply this by -1, multiply that by -1, and this becomes x equals 15 over 63. Well, what is 15 over 63? Well, x equals 15 over 63. That's our answer. Decimal form, that is 0.238. So as kind of a quick refresher on what's going on is when I read the problems, I'm looking for ands, ors, and givens and pull out what information I have and put it into probability words. Once I have all this information laid out, so that was kind of the easy part, you know, AC and silver, 60 over 63. Once I pull these out, I look and see what formula kind of works best. I know a lot of people struggle with probabilities, so sometimes maybe that's a good strategy to use. Look at which formula involves what pieces we have and what do we not have, and plug an x in there and solve for x. That might be the best course of action. Again, I did this all with fractions. You could have done it with decimals, and you would still end up with 0.238. I'm going to do one more example. So I'm going to show you what happens when we don't have the obvious pieces of information that we typically had on that first one. So an airline estimates that 90% of its eastbound flights arrive on time, and 72% of its westbound flights arrive on time. This morning, 42% of the airline schedule is westbound flights. If a flight is chosen at random, what is the probability that the flight does not arrive on time? So first read through, I'm looking for ands, ors, and givens. I'm not seeing that. Yeah, there's an and here, but this is two different probabilities separated. 90% of its eastbound flights arrive on time. That's a probability. This and is separated those two probabilities. So I'm not seeing and, or given. I do want to try and pick out what exactly is going on. What is paired together? So let's talk about eastbound flights arriving on time, westbound flights arriving on time. So I'm seeing east and west bound is one thing I'm seeing. I also talk about arrive on time this morning. 42% of the airline schedule is westbound flights. That's what we talked about. It says if a flight is chosen at random, what is the probability that the flight does not arrive on time? So it looks like we have east, westbound, on time, and not on time. So what I'm going to do, and this helps with a lot of probability problems, is draw a picture. This one I'm going to draw a tree. On these ones that you have ands and ors and all that, you can use Venn diagrams there. This one doesn't work out well with Venn diagrams. The ones that are like, I'm not really sure what's going on, Venn diagrams work. So this one I'm going to make a tree. And my branches are, well, it looks like I need to split up between east and westbound. So I'm going to do an EW, because that's two categories they gave me, east and westbounds. And then on time and not on time, because there was a point where I talked about eastbound flights arriving on time. So this is eastbound, and then we could split it up again and say on time and not on time. On time and not on time. Now let's just plug in some of these probabilities we have. So let's try and figure out this first piece, east and westbound flights. So if you go back to the problem and read through it again, you're going to find it says this morning 42% of the airline schedule is westbound flights. So what percent is westbound? Well, that's 0.42. Well, if 0.42 is westbound, then eastbound must be what? Well, what you want to be thinking about is, remember, probabilities have to add up to 1. So if this is 0.42, this must be 0.58, and both of those add up to 1. 42% are west, 58% are east. It's one or the other, right? And then let's keep going. It says up here, 90% of its eastbound flights, so we're up here, eastbound flights on time. So eastbound on time, they said 90%. So if 90% are on time, then what percentage are not on time? Well, that would be 0.10. So that adds up to 1. Those two branches add up to 1. Keep reading. 72% of its westbound flights, so we're down here. 72% of its westbound flights arrive on time. So westbound on time, 0.72. 72% on time, that means 0.28 not on time. So we have our entire tree put together. Here's what we need to find though. It says if a flight is chosen at random, what is the probability that the flight does not arrive on time? Well, how many different ways can that happen? Well, you could be eastbound and not on time, and you could be westbound not on time. So we need to find this branch and that branch. What we're going to do is it wants eastbound and not on time. So we need to multiply these together. So we're going to do 0.58 times 0.10, which is 0.058. And then you could be westbound and not on time. That means multiply. So this is going to be 0.42 times 0.28, which is 0.1176. And my question there says if a flight is chosen at random, what is the probability that the flight does not arrive on time? So it could be eastbound not in time, which is this, or westbound and not on time. So this or that, which means we need to add those two together, which 0.058 plus 0.1176, that adds up to 0.1756, which is 17.56%. So that is our answer to the question. This one is a lot tougher problem. And kids ask, well, how are you able to pick this out? Sometimes I don't get it right the first time when I look at these problems. You know, I draw a Venn diagram, I see the Venn diagram doesn't work, so then I switch to a tree. So sometimes it takes a little bit of playing around with it, and then once it feels like it works and you're not forcing anything, that's how you know you're right and things make sense. So that was my second video on probability of disjoint and overlapping events.